Today's topic has to do with the procedures or the formats that we have available to for the reporting of regression results. This is the topic: reporting regression results. This is today's topic. So I know that some of you might be tempted, if you are writing like a business report or doing some regression analysis. I think it's kind of very tempting to just copy paste the table in the way that I had done it. For example, so this is the previous example that we use for the discussion of economic versus practical, or the discussion for economic practical versus statistical significance. Remember, we have this regression model where we have the participation rate in 401k as a function of the match rate in the company, measured in percentage, the age of the plan, and the total number of employees. So that's something that we had considered previously, and you have available this example. And we consider this model where we have the participation rate in a 401k plan as a function of the match rate, age, and the total number of employees in a company. So we talk about that. And of course here, for our purposes, I had just copy paste the results that we got from Excel. Well, so unfortunately, usually when you are writing a report, a very serious business report, or if you are writing like a scientific paper, there are certain type of formats that you are supposed to follow to present the results. And today's discussion has to do with these formats, these procedures to present the regression results. So now there are different ways to do it, but I'm going to be talking about the two probably most popular alternatives or two formats. So two popular formats. To present regression results. One is the question form, which I think I have used in the past, sometimes when we're doing examples. That's the format that I use. And the second format is the table form that I have not used so far, but it's important for you to understand, especially if you are writing scientific papers. This format probably is the most popular one. Okay, so let's go one by one. Let's start with the question form. And what I'm going to be doing, when I discuss each of the forms, I'm going to present you kind of like the general formula, and then I'll be using that example so that you can see how to apply this formula for the presentation of the results. So what's the formula? And again, so this is kind of tricky because I'm saying this is the formula to present a formula. This is the formula to present the multiple linear regression results. Formula to present MLR results using the question form. Okay, so what's this formula? Well, in this formula, of course, first, you present the results in the form of an equation. So you put your dependent variable, you intercept your the coefficient corresponding to each of your dependent variables in the first line. Okay, so notice that we don't have an error in this equation. And under each of the coefficients, we're supposed to write the standard errors of the coefficients underneath each of them. we write those standard errors, we estimate. In addition to, to the question form, we always have to report the value for the R-square, the number of observations, the value of the F statistic, and the corresponding p-value. Okay, so that's the formula to present multiple linear regression results using equation form. Very simple, and again, well, I think that this is supposed to be K. Sorry, I apologize. And again, it's very simple, and I had used already in the past. Okay, so let's use our example to see how to apply this formula in the context of a specific example. So let's look at our example. Okay, so remember, we go back. So remember, these are the names of our variables. So we already remember this is the theoretical model that we were considering, and now what we're doing is we're reporting the estimated model, which we obtain using the equations for the multiple linear regression model and certain data. So this is the question, and remember the variables and the standard errors are in the table. So as a reminder, this is beta naught, this is beta 1, this is beta 2, this is beta 3, and each of these values are the corresponding standard errors. So this is the standard error for beta naught, and so on and so forth. I'm going to write them all so that you see where is it. I'm going to be getting those values, because the actual values, the numbers, are the ones that we have to place in our equation. Okay, so that's where we get the information. And of course, remember we said I will also report the R-square, the number of observations, the statistic, and the p-value. Okay, so in order for us to report the regression results using the question form, well, we first have to write the name of the dependent variable, and then we have to report the actual values for the coefficients. So this is 80.2943 plus 5.4414. This is M rate plus 0.2694 H minus 0.0001 total employees. Okay, so again, this is the beta naught. That's 80.2943 value. 5.4414. You can see it here, the second one, 0.26 and minus 0.01. And I decided to use just 3 decimals. Now the standard errors. So what's the standard error for the first coefficient? So we need the standard error for A, which is 0.777. So that's the value that I'm going to be placing here. Okay. So the second one, 0.5244. The third one, 0.0452. And the last one is going to be 0.0000. Okay. And again, we will go back. Look here, the standard error is 1, 2, 3, 4 zeros, and that's what we will copy, and 0.452, which is kind of what we wrote here for H. But for the M rate, 0.5244. You can see here that for M rate is 0.5244. Okay, the R square, 0.0996. You have to report the actual value. I'll write 0.099. Well, or actually, yes, so 0.0996. I'll write that values. N is 1,534 observations. 1,534 observations. Death statistic is equal to 56.4140, and the p-value is less than 0.01. If we go back, 56.4140, and the p-value is less than 0.01. Okay, and with that, that's basically the application of this formula for the specific context of our example. Okay, so going back, remember, we're talking about two popular formats. First one is the question form, which I already showed you, also presented an example. Now let's look at the table form to present regression results. And again, so this is kind of going to be the formula. So this is the formula to present multiple linear regression results using a table format. Okay, so first, always you need to have a title for the table. You will say regression results, and you can add the name of the dependent variable. Okay, so that people know what's your dependent variable. And then, of course, you will need a table. The table is going to have three columns. The first one is going to be for the name of the variable. The second one is going to be for the coefficient. And the third one is going to be for the standard error. Okay, so this is a table, and then here, always, you're always going to have an intercept. Well, not always, but most of the time. And then here you're supposed to write the name of all of your explanatory variables. Then here you have to report the values of the coefficients. And the standard errors. So kind of, we're presenting the same information that we had before, but presented using a different format. Okay, so we have that. And again, as before, we need to add the R-squared and the statistic and the corresponding p-value between parentheses. Now, in addition to that, when we have the table form, we usually also need to provide information about the level of significance of each of the variables. Okay, and in order to do that, usually what we do, and you will see when you're reading papers, you will see that they use stars. So usually at the bottom of the table, you add a note saying that the statistical significance is denoted using stars. Okay, so if you have one star next to a coefficient. So one star denotes significance at the 10% level. 10% level. Two stars denote significance at the 5% level. And I know that you know how to identify that. And three stars denote significance at the 1% level. Okay, so what do we do with those stars? Basically, we have to go and identify which coefficients are significant at the 1, at the 5, or at the 10% level. So just for the sake of example, let's say that the intercept is significant at the 10% level, at 5% level, so it has two stars. Beta 1 is statistically significant at the 10% level. Let's say that beta 2 is not significant at the 1, 5, or 10%. And let's say that beta k is significant at the 10% level. Okay, so by doing that, you can see that we very clearly identify which variables are significant at which level of significance. And with that, basically that's kind of the way that we present the results. Now, something that I want to emphasize, two things, because usually, you're going to have an assignment based on that. And students usually tend to forget two things when they send me the assignments. The first one is to have the name of the table. You always need to have a table with a title, and in the title you need to have the name of the dependent variable. And the other thing, students tend to forget this footnote at the table where you explain which are the levels of significance. That always needs to be in a table. There is so for tables are supposed to be always what's called self-standing. If you see a table, you are supposed to be able to understand everything that's in that table without having to go to the text. Okay, so it's important for you to have that in mind. Okay, so that's what you need to have a title in the table, and you also need to have this footnote. And actually, the footnote is you always have to write exactly the same way I wrote it here. The only thing that's going to change in the table is going to be the name of the variables, the coefficients, because you're going to have to add actual values in the standard errors, the values for their square, the n, the statistic, the value, but everything else, it has to look exactly like it is here. Okay, so let's use our example to see how we can present these regression results using the table form. Okay, so example, again, it's a table, so it needs to have a title, and the title always you have to say regression results. You can have a longer title, but you have to say regression results using this as a dependent variable. But I'm trying to simplify things for you. At the minimum, you have to say regression results, participation rate as the dependent variable. So we're very clear that we very clearly, and I'm being here inconsistent. Okay, so I'm gonna have no capitals, participation rate as a dependent variable. That was our equation. And then, our table without those three columns, variable, coefficient, and standard error. Okay, so those three names, they always have to be in the table. I mean, they're not going to change. And then for a specific example, we have the intercept and we have the three variables. And again, for tables, you have to try to be, since they are supposed to be self-standing, the names, actually, we have more space, so actually we can write the actual name of the variable, match rate. We can write age of the plan, if we could think about a table, and total employees. Without formula that we had before, we could not write that much information. I mean, the names for the variables were informative, but they were not that informative. And here we write down the coefficient. So 80.2143, we have 5.4414, 0.2694, minus 0.0001. And again, so for this one, actually, it's exactly the same order of the values that we have here, coefficient, standard errors. So I'm just basically copying and pasting those values, those values here in my table. 0.0771, 0.5244, 0.0452, 0.0000, and then we have once again the R square. We already used those values, 0.0996 and 1534. We have F stat, which is equal to 56.4140, with the p-value was less than equal to 0.01. Okay, so again, in the same table, we got the R square. We got n, the value, and also we had the level of significance. Okay, so significance, the value, n, and the R square. Okay, and again, so here we always have to write the footnote. Always is going to be the same. Not statistical significance. Don't forget this one for your homework or for your reports. Denoted using stars. Okay, stars, and then 1 star denotes significance at the 10% level. And again, that's going to depend on the p-value. See if the p-value is, and probably I'll explain you that later a little bit more, because you may get confused by that. So 2 stars denote significance at the 5% level, and 3 stars denotes significance at the 1%. Because you can simplify it here. You could say 1, 2, 3 stars denote significance at the 10, 5, and 1% level respectively. However, I'm writing it this way for you to see. Okay, so now again, don't forget this thing. We need to place the stars. So what's the level of significance for each of these variables? We go here, and then we can look at our p-values. Okay, so look, all the p-values in this case are lower than 0.01. Okay, therefore they are all significant at the 1% level. Okay? So we can place 3 stars in all of the coefficients. Okay? So because in all these coefficients, the p-values corresponding to all of these coefficients are lower than 0.01. Okay, which I guess maybe something that I should have noted here. So how do we know if it's significant at the 5% level? Well, we use 1 star, and this is kind of like a side note here. You don't have to have it in the table. It's the way to identify when to use 1, 2, or 3 stars. So first, with the 3 stars, is if the p-value is less or equal to 0.01. So we use 2 stars if the p-value is higher than 0.01 but lower or equal than 0.05. And we use 1 star if the p-value is higher than 0.05, okay, and lower or equal to 0.10. Okay, so that's kind of the rule of thumb on when do you choose, how do you choose how many stars to place in those beta coefficients. Okay, so remember, so this is the rule. Okay, to decide how many stars you place on each of these coefficients. Now, following this rule, you see in the context of our example, we put 3 stars everywhere because all of these p-values are lower or equal to 0.01. Okay, and with that, I think that that's you know, all what I have for you regarding the explanation. And you have an assignment and that I place also that you have access to. Let me save everything and I just show you what's the assignment. We use the same example that we used in the previous class. So let me see. Then I have it online. So basically here what I'm asking you is to use again the question format and the table format to report the regression results from a problem. So we have a model where we're exploring the effect of cigarette prices and family income on the demand for cigarettes during pregnancy. So that's the theoretical model that was considered, the names of the variables, and these are the results. So basically what I'm asking you to do is to present these results using both the two formats that I just discussed. Okay, so as a reminder, remember for the assignment, make sure that you follow the formula. Um, it's my experience that almost everybody is able to do the question form, but for the table form, students get sometimes a little bit confused. Remember, you always need to have a title, and you always need to have this footnote, and you always need to add the stars next to the coefficients to denote the level of significance. And the way to choose how many stars do you place is based on this little table that I have here. And basically, that's decided depending on what's the specific p-value. Okay? So, thank you very much, and we will continue next time.